Ini pada siapa itu? Ya, makan ya. Ya. Nggak, ini yang mana nggak keuangan. Mau apa? Oke. Boleh. Iya, makan. Dari hari Minggu gitu. Oke, kali kan bakar lu hari-hari.
Good morning. Good morning, good afternoon, and good evening, everyone. On behalf of Dr. Haneen and myself, Dr. Ihab, we are honored to serve as your session chairs this morning. We have an interesting lineup of topics to be presented. So I wish that you would find this session both informative and interesting. Feel free to ask any questions you would like related to the work presented. For our colleagues presenting their work, we have a time limit of 20 minutes, 15 minutes for presentation, and 5 minutes for questions. So I'm going to hand it over to Dr. Haneen to conduct the session, logistics, and timing. The floor is yours, Dr. Haneen.
Thank you, Dr. Ihab, and welcome everyone. So let's start with the first paper, ID number 77. The title of the paper is Advanced IoT-Enabled Forest Management System for Wildfire Detection and Ecosystem Protection, a case study in the Sundarbans. So let's the presenter for the speakers for the this presentation is Afroza Nahar, Muhammad Farouk As-Suhan, Kazi Ridwan, and Mustaqim Ahmed. So let's start with the first presenter of this paper. So who will be the presenter for this paper? Is there any presenter for paper ID 77? So in this case, let's move on to the next paper titled Bibliometric Analysis of Internet of Things, Research Trend on Electric Cars. The ID number of this paper is 113, and the speakers are Ajon Tri Sitioko, Rahmat Norchio, and Muhammad Surnegra, and Sheikh Somadi, and Khairi. So who will be the presenter for this paper?
Yes, I'm Dr. Haneen.
Hi.
Yeah.
So, yeah. So Ajon, who will be the presenter. So you can start now. Yes.
Okay.
Please
are you
share the
hearing my
screen.
voice?
Yes, we do
Okay.
hear your voice, but I think we need you to share the presentation, please.
Dr. Haneen, I have sent requests for share my presentation. Okay, thank you, Dr. Haneen, and the ICAISC 2025 committee for the opportunity for me. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Ajon Tristioko, and I'm honored to be here to present my study entitled Bibliometric Analysis of Internet of Things, IoT Research, 10 on Electric Cars. And I'm currently affiliated with Universitas Indonesia, as well as the National Research and Innovation Agency of Indonesia. This research is collaborative effort with Professor Rahmat Nur Cahyo, Professor Muhammad Surya Negara, Professor Sheikh Sumedi, and Heri Hindiandito. And this is the outline of my presentation, including introduction, method, result discussion, and conclusion. The background of this study is that electric vehicle, especially electric car, has advantage over conventional car, and the use of electric car can reduce carbon emission and overcome dependence on fossil fuel. And electric cars also have low operating costs and energy efficiency. And the global adoption of electric car has been significantly accelerated by rapid advancement in battery technology, charging infrastructure, and government initiatives such as incentive and subsidies. However, despite their many advantages, electric car is still face several challenges such as energy storage capacity, performance monitoring, charging station management, and overall energy efficiency. And the Internet of Things, or IoT, is a key technology in addressing this challenge by providing real-time battery condition monitoring, early detection of potential issues, and enhancing battery efficiency and durability. And our study aimed to conduct a bibliometric analysis of IoT application in electric car. In this study, we identify emerging trends, map scientific publication pattern, and provide insight that will guide future innovation in addressing the challenges of electric cars technology. In this study, we conducted bibliometric analysis as the primary research method, and we selected the Scopus database as a primary source. We choose Scopus because of its reputation of the high quality and peer-reviewed publication. We are using term Internet of Things and electric car to ensure relevant and focused result. And we are using PhosViewer as well for bibliometric visualization tool to analyze and illustrate research trends. And the result of the study show that topic related of IoT and electric car have been growing over the year. And the increasing volume of study in this area highlight that IoT growing role in enhancing comfort, efficiency, and safety in electric car technology. This development align with global effort to build intelligent and sustainable mobility solution. And the result also show the rising contribution from the developing country that indicate a strong potential for IoT to address mobility challenge in regions. So the demand for innovative and cleaner transportation system is also rapidly increasing in developing countries. And this is a list of 18 journals that publish articles related to IoT and electric cars. The journal that published the most in this area is Sensor and the International Journal of Intelligent System and Application in Engineering has 2 articles. And the 16 other journal only published 1 article. And our bibliometric analysis identified 320 keywords related to IoT and electric car in the literature. And the top 3 of keywords in this study are Internet of Things with 37 occurrence, electric car with 24 occurrence, and the charging battery with 18 occurrence. By examining the most frequent occurring keyword, we have insight into current research focus and the direction of future technological development. And the result of the PhosViewer analysis show that the most frequent used term include Internet of Things, electric vehicle, charging battery, electric car, and the digital storage. This indicate the strong research focus on technology interconnectivity and data storage system, which are essential for enabling intelligent mobility. And furthermore, new research topic that have emerged in recent years are autonomous driving and intelligent system. Autonomous driving technology have the potential to transform transportation by improving safety, lowering human error, and increasing traffic. And similarly, intelligent systems are becoming integral to the development of advanced transportation network, facilitating a more integrated and efficient mobility ecology. And the conclusion of the study is the increasing number of scientific publications on IoT application in electric car over the years. This growing trend reflects the global effort for more efficient and sustainable transportation through technology innovation. However, this study has some limitation. The analysis primarily relied on data from the Scopus database, which does not capture all relevant research. And the future study could expand on this work by using additional database such as Web of Science, PropQuest, or IEEE Explorer. And this would allow for a larger perspective and deep insight into the evolution of research land in this area. Another limitation concern the selection of journal and conference. Scientific research rely heavily on peer-reviewed academic source, but industry report, publication from independent research institution, and technical review also other valuable insight. And integrating such source into future study could help bridge the gap between academy and industry, ensuring more comprehensive understanding of IoT application in electric vehicle. And last but not least, this study indicate the autonomous driving and intelligent system are receiving increased attention and have potential for future development. Okay, that's all my presentation, and thank you.
Thank you, Mr. Arjun, for this a great and insightful presentation. I think, mashallah, you are on time. So let's start now and having the A and Q. If anyone has any questions regarding to the presentation. So, yeah.
I have a question for you about the keywords, the selection of the keywords. What is the criteria that you have followed to select these specific keywords for your research?
Yeah, okay. I'm selecting the keyword because I'm interested in this topic because the integration of IoT in electric vehicle is a crucial innovation for sustainable and smart mobility. And understanding research trend in this field help identify challenge and opportunity for the future development.
Okay, thank you very much. Thank you.
Yeah, thank you, Doctor.
Thank you, Mr. Arjun. So
Okay, thank you.
Thank you for this great presentation and very insightful one. So let's move on to the third presentation, ID paper 108, the title of this presentation is Internet of Things Enhanced Paper-Based Testing Model for the TOEFL Institutional Testing Program. The authors for this paper, Harris and Basuki Wibawa, Mocha Socardio, and Darayonto, and Mahdia. So who will be presenting this? Is there any speaker to present this paper? Yeah, this one. Yeah, Harris. So do you hear us? Harris?
Assalamu alaikum.
Wa alaikum assalam.
So I just finished my presentation in the other session, and if you would like me to start, I'm not sure about my order, but if you like me to start, I'm ready.
Assalamu alaikum, Dr. Muhammad. How are you?
عليكم السلام أهلا وسهلا الحمد لله وأنتم.
Dr. Muhammad, you will be presenting the last paper. We are now in the first and the third papers. So
Okay.
just let us make sure that
I'm ready. Once
they are
you
here and,
trigger my presentation,
not
I'm
ready.
ready.
If they're not ready to present their papers, so we will be glad that you would continue with presenting your paper. So
My pleasure.
let's go back to the paper ID 77, paper 1. Any representative of this paper? So, okay, let's move to paper number 3, 108, paper ID 108. Mr. Harris, Dr. Harris, I can see that you are here. However, I don't know if you are having some technical problems. If so, please inform us in the chat. Okay, I just need to note that for any paper to be included in the proceedings of the conference and to be published on the IEEE Explorer, the authors should present their paper in the conference. So moving back to Dr. Haneen to continue the rest of the session.
So I think let's move on and continue to the fourth paper. The ID number is 212. The title of the paper is Enabling Moving Services in Enterprise Computing. And the presenter is Dr. Muhammad, right? Dr. Muhammad?
Yes,
Dr. Muhammad Hamdi, can you start the presentation, please?
yes. Just a minute. I need to share my slide. Can you
Sure.
see the slides now? Not the slide. Can
No.
you see my screen now? Do you see it?
No.
Hello? Can you hear me? Can you hear me?
Yes, doctor, we can hear you, but we cannot see the presentation. Can you try to share the presentation again?
I'm sharing it already. Stop. Share. Okay, you see it?
Unfortunately not, doctor.
I don't know why, but I'm sharing it.
أعتقد يا دكتور أنت محتاج تختار الباوربوينت نفسه.
أنا عامل
Please.
انتاير سكرين يا دكتور.
هو أنا باين عندي علامة الشير لكن السكرين نفسها مش ظاهرة.
طب شير.
أوكي حاولي اعملي ستوب شير. طيب أحاول تاني يا دكتور. أيوه تمام.
طيب. Now you see the slides?
Yes, we do see the slides. Dr. Muhammad, just a reminder about the time. You have only 15 minutes to present and 5 minutes, followed by 5 minutes for the questions and answer. Okay, so you can start.
Okay. So we present here our theoretical framework of enabling moving services in modern enterprise computing environments. I'm Mohammed Hamdi, originally from Ain Shams University, and currently I'm working at King Abdulaziz University. And this paper has 3 co-authors, Dr. Ahmed Sami from Ericsson. Currently he works in Ericsson. Dr. Dahab from King Abdulaziz University and Prof. Khalid Al-Bahnasi from Jeddah International College. The modern enterprise computing are commonly based on cloud architecture. These cloud architecture, the main functionalities of the business inside these enterprises come from services deployed on the cloud. The problem is the data volumes. Recently, data volumes are huge. Even there is a terminology called data explosions. Actually, the enterprise computing currently is with huge dependence on the wireless infrastructure. So the connectivity and communication means is provided always through wireless infrastructure inside the enterprise or the distributed enterprise. Again, sorry. So, the idea simply is allowing nearer services inside again, I'm having here a problem of the point. So, enabling services to run inside the enterprise own infrastructure is less expensive in terms of delay and latency, bandwidth, and cost. But on the other hand, these services are running away with much more costly operation. So the idea is based on the data or the interest. So the interest here is data generation. If it's huge enough, it can pull the service from running on the away cloud nearer to the edge or fog infrastructure. If there is a high demand, even higher than the one that pulled the service to the fog or edge, the service will be deployed inside the infrastructure. Upon the request, or if the demand is lower, it can go away to the fog, can be pulled back, or can be running as its original configuration. So we are between two extremes. Getting the benefit of letting our services running on the cloud come with a huge benefit on the enterprise, and the cost of running these services away of the sources of the data, the huge data or big data in some scenarios. So here comes the idea of the moving services. Of course, we should assume our scenarios here dependent on the infrastructure, but it's just an abstract presentation for the idea. Challenges in the enterprise cloud services, the data generation, high latency and bandwidth consumption, data explosions, and need for better proximity-based data storage and processing. So we introduce the service mobility. And here come another set of challenges. In this paper, we introduce a theoretical and conceptual framing that enable a baseline for the idea of mobile service in modern enterprise computing. Here is the typical environment that we are talking about. Here is the layer, the cloud layer. The cloud layer is running based on core network, and this layer should be transparent to the users. Then the fog layer, where the services front end should be stored, should be operating. So the services are here, the front end is here, and they are accessed through the edge. So in the edge, a lot of running configuration or operation configuration will be provided of the scalability, the failover, a lot of configuration can be provided through the edge. And the network itself can be seen from the perspective of IoT or application as an ad hoc network of data producers. In the related work here, we simply provide the categorization for, or sorry, aggregation for the work and the literature. So a lot of work is addressing the mobile edge computing and fog computing. They address the replication, but not the dynamic replication. So we can, in the literature, we can replicate service from the cloud to the fog or edge, but this will be done permanently and with high costs. Other work are emphasize the architecture itself, how the integration should be done between the private cloud, the resources inside the enterprise, and the public cloud, and how to produce the public cloud, sorry, and how to manage the hypercloud, which is coordination between the public and private cloud, and include a lot of concepts of mirroring services of the public cloud to the private cloud. Again, it's a kind of static mirroring that not obey the operational data loads. Okay. Our proposed model is letting the moving service. So moving service includes replication. It's not a new concept, but if you replicate service, it will seen as if the service is hibernated at one side and moved to a new side. So in that sense, it's moving rather than replication. Of course, it comes on the account of the resources. So resources monitoring is something important at this point. Our model is depending on the service replication and clustering. So the data sources are clustered based on their preferences, on their attitude, on their mobility models. And inside these clusters, we may push our replicas. So the replication here is between services and their replicas, and we introduce the concept of hibernation and service election if we have several copies running on the same clusters, which will be closed. We are tolerant because of the load balancing, but at certain moment we should elect services to continue running and others to be hibernated or deallocated. So here is if we have a public service here, these triangles are the public services that we need inside our enterprise, but they are on the public cloud. Here is our private cloud. We may replicate the service and let it run from here, not from the public cloud, temporarily. Inside the enterprise, which is this lined area, this is the enterprise, we develop our clusters. So the clusters can be can be discovered by the wireless controllers, or based on the interest or the operation or the configuration or the preferences of the users. So they may be intra-web clusters or inter-web clusters. Inside these clusters, we may let the services be replicated once more to be nearer to their users. So we don't run it from here at some scenarios, and we let it be pushed to the data producers. After a while, the demand will decrease, then the service may be migrated back to the private cloud or to the public cloud. So we assume components of the enterprise network to be the wireless controllers, wireless access points, hybrid cloud services. The MC mobile edge computing-based service distribution, which is the name of the architecture we propose, is dynamically allocation conceptual set of procedures that enable dynamically migration of the service. The classification and allocation are important concepts in our framework. So where exactly you are going to deploy your service in the fog edge layers, where they are represented as minutes or inside the clusters. So a lot of criteria can be employed there, like importance of the service, frequency of usage, or resource consumption. The key challenge, the network integration. So we don't build from the scratch. So the network are the infrastructure are there and running, and you need to employ your protocol transparently of the usage, security and authorization. Not all of the services are authorized to run from anywhere. Some of these services need a lot of other resources. And while migrating the service from a place to place, what to do with these open sessions to this specific service? Actually, this is these questions has been answered in some of our current research. One of the important questions is the performance, and of course the context and consistency. So if we have two replicas, they need to communicate together in the background to exchange the transactions to achieve the steady state of the service. So are all of the transactions will be commit or rollback? So the consistency problem and the context. Context here means the service configuration parameters need to be exchanged correctly between the different replicas of the services and the different operation scenarios. The key contributions we present using this theoretical framework is the service replication and allocation, the
Dr.
mobile
Mohammed,
subscriber. Yeah.
sorry, Dr. Mohammed, sorry for the interruption, but please wrap up. So you have a couple of minutes, okay? Thank you
Okay.
very much.
Okay. So the contributions are the allocation, the enabling the movement of the service, mobile subscriber clustering, enhancements for the hypercloud model, service classification and decision, and the replication decisions. The theoretical and conceptual framing is the key contribution again. It enable a better operation scenarios for the especially the huge data footprint scenarios in the modern enterprise network. Future work, we are currently using several simulation tools to implement our concepts. We already had currently a prototype configuration using one of the available simulators, and we consider real world case studies. Thank you very much, and back to the chair for any questions.
Thank you, Dr. Muhammad, for the great presentation and very insightful design and model for Internet of Things and enterprises businesses, especially with the growth and the increase of the enterprises businesses. So let's open the door for the questions and answers for the audience, for our guests. Does anybody have any question? So thank you, Doctor. I'm really interested and curious about this topic, and I have a question regarding to the IoT. The idea of using a new technology, the application of the Internet of Things in the enterprises, it's really interesting. However, how this model tackle the challenge of the data accuracy and the downtime of the services in your design or in your model?
Thank you for the question. Actually, this is one of the strengths of the model, as the hypothesis that we have saying that having the services near to the for your question in an IoT scenario, close to the sensors, for instance, will keep lower latency, better data dissemination, and low costs, and will, of course, keep the bandwidth for other use in the enterprise. So, assuming a building, we have a lot of sensors, and there is an event in this building, so all of the sensors are working like crazy, and they are generating gigs of data. So, instead of letting this huge amount traveling through the infrastructure to the cloud service, the data storage cloud service, we'll replicate this service inside the environment, and will collect this data temporarily. Once the demand will go down, and of course, the data collection in this scenario will come with low latency and low transmission cost. Later, when the event ends, we assume we can easily let this service migrate back to the edge. And if the demand go lower and lower, it will be pushed to the cloud. So the proposed solution or the proposed protocol come with a lot of benefits for the scenario you assume for IoT inside an enterprise computer.
Thank you, Doctor, for the great clarification of this point. So, Doctor, thank you very much, Dr. Muhammad, for this valuable presentation. So let's move now to the...
Thank you.
Thank you very much. So let's go now to the third paper, ID 108, Mr. Harris. So the presentation title, Internet of Things, Enhanced Paper-Based Testing Model for the TOEFL Institutional Testing Program. So shall you start, please?
Okay, thank you. Good afternoon, ladies and gentlemen. Thank you for coming to my presentation today. I'm glad to meet you all. Before starting our presentation today, let me introduce
Mr. Harris, we can't hear you.
In
Yes.
1979, and my early education is
Excuse me, Dr. Harris. We can't hear very well. The sound is not clear. Could you please?
Yes.
We really can't hear you. Please, could you please? Could you please move closer to the mic? Your voice is.
With my video in the morning, I will create a video. No problem.
No, it's not acceptable. You're going to present the video, doctor.
Yes.
We need you to present the paper yourself, please.
Direct. Okay. Semuanya. Like this?
Okay, yes.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Walaikum salam wa rahmatullahi.
My name is Haris. The title is IoT Enhanced Paper-Based Testing Model for the TOEFL Introduction Testing Program. Abstract. This study developed an IoT Enhanced Paper-Based testing model for TOEFL ITP, addressing a grading delay, human error, and data security issues. Importance of English proficiency. TOEFL ITP is widely used for academic and professional purpose. Challenges in traditional paper-based tests. Manual grading is slow, prone to errors, and lack data security. Role of IoT in education. IoT enhanced learning through automation, real-time data collection, and secure cloud storage. Research objective, develop an IoT enhanced PBT model to improve efficiency, accuracy, and security in TOEFL ITP assessment. Internet of Things, connect physical and digital system for automation, real-time data exchange, and security. IoT in testing enables automatic testing, test scanning, real-time grading, and secure cloud storage, reducing error and delay. TOEFL ITP structure consists of listening comprehension, structure, written and written expression, and reading comprehension. Limitation of traditional paper-based TOEFL ITP manual grading is time-consuming, error-prone, and lacks strong data security. IoT integration in TOEFL ITP improve efficiency, minimize human intervention, and enhance security for standardized testing. Approach, mixed methods research combining quantitative and qualitative. Participant is 25 TOEFL ITP test takers from diverse backgrounds. Data collection, quantitative error rate analysis, grading time comparison, qualitative survey on usability, security, and user satisfaction. The table presents the demographic profile of 35 respondents who participated in the pilot testing of the enhanced paper-based testing model for TOEFL ITP. Gender distribution, the respondent consists of 56% male and 44% female. Education level, 6% are undergraduate students and 40% are postgraduate students. Experience with technology, 40% have high technological experience, 40% have medium experience, and 20% have low experience. The table presents the average score from a qualitative survey evaluation based on three key aspects, rate on a 1 to 5 scale. Is of use, score 4.6, indicating that users found the system highly user-friendly. Data security received the highest score of 4.8, showing strong confidence in the security of the system. User satisfaction scored 4.7, suggesting that the overall user experience very positive. The result highlight the effectiveness and reliability of the system in terms of usability, security, and user satisfaction. The bar chart compare the average scoring time in minutes between traditional PBT and IoT enhanced PBT. Traditional PBT takes 120 minutes, which is significantly longer. IoT enhanced PBT reduced the scoring time to 60 minutes, showing a 50% improvement in efficiency. Results, this indicate that using IoT technology in paper-based testing help to streamline the scoring process, making it faster and more efficient. Comparative study, the table compared key performance metrics between the IoT enhanced PBT system and traditional PBT method. Scoring time, the IoT enhanced system significantly reduced scoring time from 120 minutes to 60 minutes. Error rate, the IoT enhanced system has much lower error rate 2% compared to the traditional method 10%. User satisfaction, the IoT enhanced system achieved a higher user satisfaction score 4.7 compared to the traditional method. Data security, the IoT enhanced system also provide better data security 4.8 than traditional method 3.5. Overall, the IoT enhanced PBT system outperform the traditional method is efficiency, accuracy, user satisfaction, and data security. Result and discussion. The diagram illustrates the software of architecture of the IoT PBT, the system for Tuple IoTP. The architecture integrates cloud computing, web application, and IoT devices to enhance the traditional PBT exam. The Tuple IoTP exam web application manages the test administration and connect to the API IoT PBT for processing responses. The system utilizes cloud computing for storage, data processing, and real-time access. The takers still receive paper-based question, but their answers are recorded using an IoT PBT device, which digitizes the response and sends them to the system. The IoT PBT device provides an interactive interface for selecting answer, improving accuracy and efficiency in grading. The image shows the initial display screen of the IoT PBT device for Tuple IoTP. Screen display the test name, instruction prompt, and device feature for answer. Select a button A, B, C, and each represented by different colors. Navigation button, prep and next allow the test taker to move between questions. The result, this IoT enhanced device is designed to facilitate answer selection in paper-based Tuple IoTP exam, improving efficiency, accuracy, and automation in test taking and scoring. Conclusion, the implementation of the IoT enhanced paper-based test system significantly improved the efficiency and accuracy of traditional testing method. The result showed that scoring time is reduced by 50%, error rates decrease, and user satisfaction and data security are enhanced. The integration of cloud computing and IoT technology streamline the examination process, make it more reliable, faster, and user-friendly. This innovation demonstrates the potential of IoT in modernizing assessment system, ensuring a more efficient and secure testing environment. That's all my presentation. Thank you.
Thank you, Dr. Harris, for this great presentation. It's really unique and very interesting to use the IoT in this discipline, especially for the TOEFL test exams and all these kind of institutions that offer tests. So is there anyone have any questions? The door is open for questions and answer. Oh, so Dr. Harris, can you just give a brief or a clarification of the model that you have for your strategy that you developed based on the results of the errors and based on the results of these strategies you have presented?
The result from fit trial in the class uh, on on the class simulation for PPT with paper-based only and paper-based with IoT advanced.
He has more questions.
Good morning, Dr. Harris. I have a question, maybe two questions for you. We haven't seen a model hardware implementation of your system because this is an IoT-based system. So to clarify things, first of all, this is a grading system, right? This is a system used for grading the TOEFL. So have you used cameras, sensors? What type of hardware implementation have you conducted in your research?
I don't understand.
Okay, I'm going to move to the next question. You have said that you have tested your system through 25 participants, correct?
Yes.
So do you think that the results from this type of sample or just the size could be biased and the results, especially the error, could be a little bit incorrect?
Yes.
I think you're having some issues in your sound system. So I'm moving back to Dr. Haneen to conduct the rest of the session. Thank you very much, Dr. Harris.
Okay, thank you.
Thank you. Thank you, Dr. Ihab. So I think, yes, we still have one paper left, paper ID 77. I don't think so we have the present. I don't think so we have the present. Okay. So we'll be waiting for the presenter for paper ID 77.
Ruda, the author.
So,
Yeah. Could you, Dr. Khalid, could you enlarge the presentation?
Yeah. Just give me,
Maximize it.
do you see it now?
Good. Go ahead.
Pardon me.
Yes, Dr. Muhammad.
Are there any other presentations in the session or
We still have one
apparently
presentation left where we have to wait for them till 10:20. So yes, we will be waiting. So
okay,
we're not
so
sure. We're waiting for the presenter to present the paper. Okay.
it was a great pleasure to me to giving me this opportunity, and I'll quit now for another appointment. Thank you very much and see you.
Thank you, Dr. Muhammad, for your presenting the presentation. Thank you.
Thank you. Thank you.
Thank you very much for attending the sessions. It's really interesting topic that has transformed and diverse among the Internet of Things. So this is the end of the session. If you have any questions or a clarification, you can communicate the speakers. Thank you very much.